Just a few days after the ceasefire took effect, Iranian state media claimed that USS Abraham Lincoln and USS Tripoli were in their sights. This may have been nothing more than a one-sided message from the IRGC. They most likely understood very well just how difficult that would be, but they made the claim anyway. Because a U.S. carrier strike group is not simply a military target. It is one of the most heavily defended mobile fortresses on Earth. More precisely, it is not an ordinary target at all, but an extremely unforgiving physics problem. To put a missile on USS Abraham Lincoln, you would have to solve three completely different technical problems at the same time.
Three technical problems must be solved
simultaneously. First, you would need to determine the ship's position in real time while it is constantly moving. Next, you would have to update the missile's trajectory while it is in flight. Finally, you would need to launch enough weapons at the same time to break through 4 concentric layers of active defense. Each individual problem is already a major engineering and technical challenge. Put all 3 together, and the level of difficulty comes very close to the impossible. We cannot verify that claim, but we can test it with math. And the math leads to a far more interesting question than the attention-grabbing headline does. Before getting to the numbers, we need to understand what Iran is actually aiming at. They are not aiming at a single ship. They are aiming at a massive defensive bubble. Roughly 9 warships, about 75 aircraft,
the carrier strike
and layers
group,
of overlapping sensors with a reach greater than the entire air defense radar networks of many countries.
A flexible force for any
operational theater. At the center of that
theater.
entire structure is USS Abraham Lincoln, a nuclear-powered aircraft carrier weighing about 100,000 tons, one that has been at sea long enough that no one outside U.S. Strategic Command knows its exact current location. At least not publicly and not with absolute precision. If you were an Iranian mission planner sitting in a command bunker right now, your job would not simply be to press a button and launch a missile at a ship. Your real job would be to find that bubble, track it continuously in real time, get a missile inside that protected zone, and keep that missile alive long enough to reach the center, all while facing a system that has been designed for more than half a century specifically to destroy exactly that kind of missile. That system operates through 3 distinct defensive lines, 3 consecutive gates. You do not get to choose which gate you want to face. You have to go through all of them in order. Fail at the first gate, and you never reach the second. Survive the second, and the third is still waiting. And each gate follows its own set of physical rules, uses different weapons, and has a kill probability that changes with speed, altitude, and angle of approach. The first gate is where most attacks end before they ever really begin. USS Abraham Lincoln, hull number CVN-72, is a Nimitz-class nuclear-powered aircraft carrier, 1,092 feet long and weighing more than 100,000 tons.
Lincoln does not move alone.
As the ship itself is not the entire defensive system, Lincoln does not move alone.
Positioning themselves to
it operates as the center of an entire carrier strike group, essentially a constellation of warships working together as a single defensive organism. Picture it like an onion with 4
carrier strike
concentric
group is
layers.
like an onion with layered
Each
defenses.
layer is a
the
different
outer layer
weapon
is
system
long-range
covering
detection
a
and
different
defense.
range
The
band.
inner layer is close-in
To put a
protection
missile
for the
on
carrier.
Lincoln,
Each layer
you
adds
do
to the
not
group's
just have to break
survivability.
through one layer. You have to break through all of them almost at the same time. The outermost layer is the SM-6, officially the Standard Missile 6, or RIM-174, with a range of more than 130 nautical miles. At that distance, a missile aimed at Lincoln can be intercepted before its own seeker radar ever locks onto the target. In other words, the SM-6 can kill the incoming missile before that missile actually sees the ship it is trying to hit. The second layer is the SM-2 Block 3 Bravo, with a range of about 90 nautical miles, designed for fleet area defense against aircraft, cruise missiles, and anti-ship missiles that survive the outer ring. The third layer is the ESSM, the Evolved Sea Sparrow Missile, or RIM-162, with a range of more than 27 nautical miles, built specifically to defeat high-speed maneuvering anti-ship missiles, including supersonic ones designed to slip past the outer intercept layers. And the final layer, the last gate right next to the target, is the Phalanx CIWS, a 20-millimeter Gatling gun firing about 4,500 rounds per minute, operating autonomously without waiting for a human command. It sees, tracks, and fires on its own. That is the deliberate trade-off built into the design. The system gives up broad, generalized defense in exchange for a structure that makes the ship impossible to kill with a single missile. 4 layers, 4 different physics problems. A missile trying to reach Lincoln has to solve all 4 in real time under
Layer
fire,
1.
while
The outermost
every
layer
layer is
confronts
actively
long-range
trying to
detection
kill
and
it before
atmospheric
it
physics.
gets to the ship.
Layer 3. Closer threats
But the
involve
reports
electronic warfare
did
and
not
signal
only
processing
name Lincoln.
challenges.
They also mentioned Tripoli. And to understand why targeting Tripoli would be even harder, you first have to understand what Tripoli actually is. A lot of people see the LHA designation and think of an amphibious assault ship, a transport ship, a soft target. That is wrong at the most basic level. USS Tripoli, hull number LHA-7, is an America-class ship, weighing about 45,000 tons at full load and measuring 844 feet long. In the Lightning carrier configuration it is currently operating in, the ship carries more than 20 F-35B stealth fighters, more than 20 F-35Bs, which is more combat aircraft than the entire fighter fleet of most nations in the region. This is not a logistics ship. It is a floating airfield, and those 5th-generation aircraft were moved into the theater to break the back of what remained of Iran's coastal defense system. Tripoli itself is no weak target when it comes to self-defense. It has 2
The RAM
RAM
launcher
launchers,
provides
meaning
point defense,
rolling
using
airframe
infrared
missile
and radar
launchers
guidance
for
to
point
track and
defense using
intercept threats.
infrared and radar guidance. It has 2 ESSM launchers for medium-range defense. It has 2 Phalanx CIWS systems for extremely close-range engagement. But those are only the last resort. Just like Lincoln, Tripoli does not operate alone. It moves within an expeditionary strike group that includes Aegis-equipped destroyers. Those destroyers carry vertical launch systems loaded with SM-2 and ESSM interceptors, extending the entire layered defense architecture out to the perimeter of the strike group.
Tripoli
The systems on
equal
Tripoli
inner
itself
layer.
are only the
Destroyers
inner
equal
layer.
outer layers.
Everything beyond that is provided by the destroyers around it. So calling Tripoli an easier target just because of its LHA designation is like looking at an armored SUV and assuming it has no armor because the brochure calls it a family vehicle. The designation tells you the mission. It does not tell you the survivability architecture. 2 ships, 2 floating fortresses. So the question now is, what Iran still has left that could break through them? And the answer does not begin with the missile inventory. It begins with a much simpler question. Does Iran actually know where these 2 ships are right now? This is where most analyses stop too early. People focus on the missile, when the real issue is everything that has to happen before the missile is even launched. These ships are not standing still. USS Abraham Lincoln can make about 30 knots, while USS Tripoli cruises at more than 22 knots, and both maneuver unpredictably around the clock. Now look at the physics of a long-range strike. Let us assume Iran has its best weapon available, a modern anti-ship ballistic missile such as Khalish Fars or Zulfiqar Basir, coming down at Mach 3 or faster. Even at that extreme speed, covering 270 nautical miles still takes roughly 8 to 10 minutes. In that short period, a carrier moving at 30 knots can shift by nearly 5 nautical miles. That means if you fire at the ship's location at the moment you push the button, by the time the missile arrives at those exact coordinates, the real target has already moved about 5 nautical miles away. The missile's terminal seeker cone is simply too narrow to recover from an error that large. To close that gap, Iran would need a continuously functioning, unbroken data nervous system. Airborne drones or surviving coastal radars would have to track the ship in real time and pass that data through a secure command and control network all the way to the launch unit. But the problem does not end there. While the ballistic missile is arcing through the atmosphere, it would still need mid-course updates telling it exactly how the ship is turning. Only then could the seeker activate in the right patch of sky during the final phase. Without that continuous data link, the missile's speed is almost meaningless. At that point, you were just throwing a perfectly precise rock at a car that has already driven away. Now look at Iran's targeting chain after 38 days of Operation Epic Fury. Its coastal radar network had been hit in more than 600 naval strike packages. Maritime surveillance aircraft had been shot down or forced to stay grounded. More than 2,000 command and control nodes had been destroyed over the course of the campaign. That chain is no longer merely weakened. It is broken. Without ISR still operating effectively, Iran cannot know exactly where Lincoln and Tripoli are right now. And if it does not know that, the missile has no specific place to go. That is problem number one. But let us be generous. Let us assume the chain is somehow still intact. The coordinates are still live. The launchers are still ready. Iran knows exactly where the ships are. There is still a second problem, and this time, it is purely arithmetic. Does Iran actually have enough missiles to get even one through? To understand that, you need to understand the concept of saturation in naval warfare. A single missile, no matter how sophisticated, approaching a fully operational Aegis carrier strike group would still face 4 defensive layers and hundreds of interceptor rounds already available. The probability of one missile penetrating all 4 layers is close to 0. To give even one missile a real chance, you have to flood the system. Analysts call that saturation, meaning launching enough weapons at the same time from enough directions that the defensive layers cannot service every incoming track before impact. The number required is not 2 or 3 missiles. It is dozens attacking simultaneously from multiple directions, coordinated in real time. That is the minimum physical threshold. Below that threshold, the math says no. Now look at what Iran still has available in the relevant Arabian Sea range band. Khalij Fars, Iran's most widely available anti-ship ballistic missile, has a range of about 160 nautical miles. Meanwhile, Lincoln and Tripoli are operating out in the Arabian Sea, hundreds of nautical miles from Iran's coastline. Khalij Fars cannot reach them. Zulfiqar Basir could theoretically reach them with a range of about 370 nautical miles, but its launch infrastructure has been systematically targeted. The surviving mobile launchers are under continuous ISR surveillance by U.S. assets. A launch means immediate detection, and immediate detection means a counterstrike almost right away. And even then, if a launch still somehow takes place, Iran would still have to coordinate dozens of missiles fired at once from multiple directions, while its command and control network has already lost more than 2,000 units. Before the campaign, Iran was estimated to possess around 2,500 to 3,000 ballistic missiles. After 38 days, the remaining inventory was only about 1,000, meaning more than half had been lost. Launch rates had dropped by more than 90% by late March. Production infrastructure had been destroyed by 85 to 90%. Hundreds of mobile launch vehicles had been neutralized. In short, Iran has to solve both problems at the same time. Know the ship's exact positions in real time, and coordinate enough simultaneous missiles from launchers that have not been destroyed. Miss either one, and the missile never reaches the target. After 38 days of epic fury, Iran is missing both. The physics has been very clear, and yet that statement still appeared across diplomatic channels before this video was even recorded, which means something in this equation is still working effectively, just not the missiles. There are 3 different failure modes here, and any one of them is enough to break the entire attack chain. But the most important thing they all have in common is that these are all systems engineering problems, not just hardware problems. Iran may still be able to manufacture more missiles. What it cannot rebuild in time is the nervous system those missiles need in order to function. The ISR layer, the C2 network, the ability to coordinate synchronized launches. Without the system, the hardware becomes almost meaningless. And this is where we arrive at the most interesting point. The Aegis architecture was never built to intercept signals. Aegis intercepts objects, physical objects carrying kinetic energy like missiles, warheads, or projectiles. The SM-6 handles threats at ranges beyond 130 nautical miles. Phalanx takes care of the last few hundred meters. Every layer was designed around the physics of a mass moving along a trajectory. But a media statement is not a physical object. It has no ballistic arc, no radar cross-section, no thermal signature. It moves at the speed of a signal, and Aegis has no layer that can intercept a signal. That asymmetry between what the system was built to stop and what it cannot touch is the real subject here. Not the missile, but the gap. The physics of the strike itself has already been settled. 3 gates, 3 problems that are nearly impossible to solve for Iran's current degraded capabilities. Those ships cannot be reached right now, not by the missile inventory that remains, not with a targeting chain that no longer functions, and certainly not with a saturation salvo that Iran cannot coordinate. The hull is safe, physics all that guarantees it. But there is still a harder technical question, and it does not have a neat answer. When you design a system to defeat every kinetic threat inside the expected
The Aegis
threat
system was
envelope,
engineered to model
what
kinetic
happens
threats
when
like
the
these
threat
missiles.
shifts entirely into
Its
a different
design
domain?
parameters focus on physical
What happens
objects,
when
ensuring
the
precise
weapon
detection and
is
response.
no longer a warhead, but a signal? No interceptor was ever designed to solve that problem. And the engineers who built Aegis understood that very well. They built the system for the kind of threat they could model, the kinetic one. So the final conclusion is this. We can say the ships are safe, but we cannot say the system is absolutely complete. Those are 2 different statements, and only one of them remains an open problem in modern engineering. Think carefully about that.